This is going to be a pretty quick video, which is going to be a good change from the last few, right? So we've kind of gone up and away as far as the number of minutes in our videos. This video is going to be about solving logarithmic equations. So in the last video, we kind of focused on what logarithms were and about their graphs, their parent functions, and all that jazz. And this one, we're going to kind of get an introduction to solving logarithmic equations. In our next video, we're going to take that one step even further and talk about some of the properties. Okay, so without further ado, here we go. We're going to start and jump right off the bat with an example. And in this example, we're going to use a really simple tool in our tool belt. Okay, so what we have here is we have log base 49 of x equals 3 halves. Okay, so to solve this equation, we're trying to get to this x. So normally in an equation, we're trying to get rid of all the stuff that's attached to x by doing the opposite. We can't really get at this x because it's stuck in this logarithm. And so what we do to fix that problem is we switch and put this into exponential form, because then we can actually do something with it. Okay, so if we put this in exponential form, we have the base of 49 raised to the power of 3 halves. That equals x. So now we've got x all by itself. We just got to clean up this mess. So this is the square root of 49 cubed. So the square root of 49 is 7. So we end up with 7 cubed equals x. All right, so 7 cubed, in case you didn't know, is 343. So our final answer is x equals 343. Awesome sauce. That's it. That's all there is to that problem. Okay. So in order to do much of anything more complicated, we're going to have to learn a few properties. Our first property is the property of equality. It is very, very similar to the property of equality with exponential functions. It says that the log base b of x equals the log base b, notice the bases are the same, of y if and only if x equals y. So this is very, very similar to the property of equality for exponents. This is exactly what I just said. So let's look at an example using this. Okay, so our example is going to be the log base 3 of x squared, that's a 2, minus 15 equals the log base 3 of 2x. Now it's really important that the bases be equal. In this case, they are. So what we can do now is we can just drop the logs and we can just set the insides equal to each other. So we end up with x squared minus 15 equals 2x. All right, so we've got a quadratic here, so we're going to end up solving this by factoring, it looks like. So let's head in that direction and let's subtract 2x from both sides and hope for the best. So subtract 2x, subtract 2x. So we end up with x squared minus 2x, because those don't combine, minus 15 equals 0. So does this factor? Yes, indeedy it does. So it factors. For the first slot, we have x and x, because x times x is x squared. For the second slot, we're going to use 5 and 3. Now, to get a negative 2 in the middle, this has got to be negative, and this has got to be positive. So x ends up equaling positive 5 and negative 3. Now, when we plug these back in here, and we plug in a 5, that works out totally fine. But if we take and we plug a -3 in here, that gives us a negative inside of this one because it gives us -6. This one gives us a negative as well, actually, because it's going to be 9 minus 15. So it's going to be -6 in here as well. So that sounds good, but the problem is the log of a negative number, the log base 3 of a negative number is undefined. So this answer doesn't work. So our final answer is just x equals 5. So normal log of a negative number is undefined. Okay, so those kind of answers that are going to evaluate out to negative inside of the logarithm, undefined. That's the end of the story. And that's it for this video. I told you this one was going to be short and sweet, and I wasn't lying. In our next video, we're going to talk about some more properties of logarithms and what to do with those. It'll be a little bit more meaty, but still not too bad. We'll see you there.